Alright, so that's all well and good, but how about we up the ante a little bit and do a couple of harder worked examples? So let's check that out.
So in this worked example, it says the remainder when x cubed plus kx squared plus x minus 2 is divided by x minus 2 is equal to 20. Find the value of k. So what we're actually looking for is this value k here. Now what we know is that when I divide this function here by x minus 2, I'm going to get a remainder of 20. So therefore, if I substitute in p of 2, I'm going to get a remainder or an answer equal to 20. Alright, so let's go through and do that. What I've got here is I'm going to write out p of x is equal to x cubed plus kx squared plus x minus 2. And what I know is if I substitute in p of 2, because I was saying negative 2 here, x minus 2, so if I substitute in p of 2, I'll get p of 2 is equal to 2 cubed plus k 2 squared plus 2 minus 2. So that therefore is equal to 8 plus 4k plus 2 minus 2. Well, the 2 and the minus 2 are going to cancel each other out, so you just got 8 plus 4k. Now I know that the remainder is actually equal to 20, not 8 plus 4k. So what I can say is p of 2 is actually equal to 20. Now instead of writing p of 2, because they're equal, I can actually write 20 here instead. So I can write 20 is equal to 8 plus 4k. And of course now you can see that I can actually go through and rearrange and solve for k, because that's what I'm actually looking for. I'm actually looking for the value of k, as the question says here. So to do that, I subtract 8 from both sides, so I get 12 is equal to 4k. And when I divide both sides by 4, I'm going to get 3 is equal to k. Therefore, k is equal to 3. Now I wouldn't expect you to do this in your working out, but what you could actually go through and do is just substitute in 3 here into the equation. So we could call this p of x once again, and we could say is equal to x cubed plus, now instead of writing k, I write 3, so you go 3x squared plus x minus 2. Alright, go through and substitute in p of 2 now, so you're going to go p of 2 is equal to 2 cubed plus 3 times 2 squared plus 2 in brackets minus 2. Now 2 cubed is equal to 8 plus 3 times 4 plus 2 minus 2. Now 8 plus 3 times 4 is 12 plus 2 minus 2. And of course 8 plus 12 is 20 plus 2 is 22 minus 2 is equal to 20. So we know p of 2 is equal to 20. So that actually holds true to what it said here, where it says the remainder when x cubed plus kx squared plus x minus 2 is divided by x minus 2 is equal to 20. Therefore, find the value of k. Well, when I substitute in 3 for k here, what I end up getting was when I put in p of 2, I got a remainder of 20. So we know this is actually true. Alright, so it's time to press pause and attempt the following question. That is, it is known that x plus 1 is a factor of x cubed minus bx squared minus 2x plus 1. Find the value of b. Remember to press play once you're done so you can check your solutions out against mine. Alright, so welcome back once again. Now, we know that by reading the question it says it is known that x plus 1 is a factor of x cubed minus bx squared minus 2x plus 1, and we need to find the value of b. Now, if x plus 1 is a factor of this here, we know that p of negative 1 will give us 0. Alright, because we'll call this here p of x. We know if we substitute in negative 1, because it's a factor, we'll get an answer of 0. So what I've done is I've gone through and I've called that function p of x here. And what I've substituted in is p of negative 1, because it says x plus 1 is a factor. So you go p of negative 1 is equal to negative 1 cubed minus b times negative 1 squared minus 2 times negative 1 plus 1. Now negative 1 cubed is negative 1, negative 1 squared is positive 1, negative 2 times negative 1 is positive 2, plus 1 at the end. Now what we've got here is our negative b times 1 is negative b, and our negative 1 and our positive 1 here will cancel it out. So we've got negative b plus 2. Now because I know that p of negative 1 will get us an answer of 0, what I can actually do is I can write in 0 here instead of p of negative 1. So I've written 0 is equal to negative b plus 2. And of course now I go through and solve for b, so what I need to do is minus 2 off both sides, just here and here like so. And I get negative 2 is equal to negative b, and when I divide both sides by the negative, I end up getting b is equal to 2.
Alright guys, so I know we just touched on it, but let's actually have a look at a couple of worked examples on the factor theorem. Let's check it out.
Now this worked example says find a factor for the polynomial p of x is equal to x cubed minus 5x squared minus 2x plus 24. Now basically the only way to do this is through a bit of trial and error. So There is a little bit of a hint that you can use first of all though, and you can see that we've got the number 24 here at the end, so we know that the factors really must actually be factors of 24. So what I'm going to do is I'm going to test to see if x plus 1 is a factor. So is x plus 1 a factor? Alright, well to test that, what we need to do is we just need to find out p of negative 1. So write p of x, first of all, p of x is equal to x cubed minus 5x squared minus 2x plus 24. And we want to know if x plus 1 is a factor. So what I'm going to do is I'm going to substitute p of negative 1. And I go negative 1 cubed minus 5 times negative 1 squared minus 2 times negative 1 plus 24. Alright, negative 1 cubed is negative 1. Negative 1 squared, well that's going to be negative 5 times 1. Minus 2 times negative 1 is positive 2 plus 24. Negative 1 minus negative 5 times 1, well that's going to be negative 1 minus 5 plus 2 plus 24. Which gets us negative 6 plus 2 is negative 4 plus 24 is 20. So because p of negative 1 is equal to 20, we know that there is actually a remainder. And if there is a remainder, therefore it is not a factor. Therefore, x plus 1 is not a factor of p of x. Alright, well let's try out another one now. Let's try, for example, x plus 2. So I want to see, is x plus 2 a factor? Alright, well let's substitute in p of negative 2 then, because I want to see if x plus 2 is a factor. So alright, p of x again is equal to x cubed minus 5x squared minus 2x plus 24. Alright, I want to find out if x plus 2 is a factor, so I write p of negative 2 because I write the opposite. And I write negative 2 cubed minus 5 times negative 2 squared minus 2 times negative 2 plus 24. Negative 2 cubed is negative 8. Negative 5 times negative 2 squared is 4. Negative 2 times negative 2 is positive 4 plus 24. That gets me negative 8 minus 20 plus 4 plus 24. Negative 8 minus 28 is negative 28 plus 4 plus 24. Wait a second, 4 plus 24 is 28, so negative 28 plus 28 is equal to 0. Therefore p of negative 2 is equal to 0, and because p of negative 2 is equal to 0, we can say therefore x plus 2 is a factor, because p of negative 2 is equal to 0. So therefore we know that x plus 2 is a factor of p of x being x cubed minus 5x squared minus 2x plus 24.
Alright guys, thank you very much for tuning into today's lesson, which was all about how to work with the remainder and the factor theorems. Now make sure you stay tuned for the very next lesson, because we're going to look at how to apply these skills in order to be able to factorize polynomials, that is cubic and quartic expressions. So of course, like always, say hi to your maths teacher for me. Morsey out.